Natural. So the natural or the counting numbers are the simplest classification of numbers that we have. 1, 2, 3, 4. What's the next classification of numbers we would have? A whole number, which means you do what? You add 0. The next classification of numbers would be integers, which means they take, or what is integers then? Yeah. The negative and the positive whole numbers. That is correct. What's after that? Rational. What are your rational numbers? Kind of. What type of fractions? You can write it as a fraction. And as far as decimals are concerned, what type of decimals can you write as a fraction? Terminating, which means they're going to stop. And repeating decimals like 0.333333, which we can write as 1/3, is another rational number. The next thing, what is it if it cannot be written as a fraction? Irrational. And if we talk about irrational numbers, can you give me an example? The square root of 7. The square root of anything that is not a perfect square. E is another example, which 2.718. Remember the song? E 2.718. That's the value of it. Approximate value of it, just like, what's another one? Pi, which has an approximate value of 3.14. So the next thing that your lesson talks about is the number line. And if we look at a couple of questions coming up in your homework assignment, you have 1 through 3 done, correct? The question number 4 says the numbers of arithmetic are 0 and the positive real numbers. How do we define positive real numbers? Well, when we define that, it goes back into looking at what we have with the number line. As you look at the number line, we know that a number line goes on forever. Do you know what we call that when we move on to the right forever? It will be positive values. Positive values are to the right of 0, and we refer to 0 as the origin. If you go to the right and you keep on going, it's going to go to positive, and that symbol, do you know what that symbol is? Infinity. So it goes to positive infinity, but also it's going to keep on going in the negative direction to negative infinity. When you are creating that number line, you want to make sure that you are able to put even increments and then number them. And keep in mind, in the negative direction, the first value is -1, the second value is -2, the third value back is -3. If you were to compare, how would you compare -3, the value of -3 compared to the value of -1? -3 is less than -1, because when you want to compare numbers, you look on the number line, and anything that is to the right of the other value is going to be greater than. So the question was, how do you define a positive number? On the number line. Anything that is to the right of 0 on the number line is going to be a positive number. 0 and the positive real numbers. How do you define positive real numbers? There's your question. You have your assignment in front of you. You should have number 4 labeled, or put down number 4 and ready to answer question number 4. Anything to the right of 0 Any value greater than 0 is what we classify as a positive real number. And I forgot that when we reviewed in like the bell ringer, the classification of numbers, I forgot to mention that what do we classify the reals in, or what do we classify the rationals and irrationals as? Those are real numbers. So question 4 should be done. We define positive real numbers as any number greater than 0 on the number line, or any value greater than 0 is a positive real number. Is 0 positive or negative? Neither. And when I talk about numbers to the right of 0, even though I don't have 1/2 marked, is that still a positive real number? Yes. So it's just not the numbers that you see that are marked. The next thing we have then, you've already worked with addition and subtraction of fractions. What do you know is true when you add or subtract fractions? You have to have a common denominator. And then you just add the numerators, keep that denominator, or subtract the numerators and keep that denominator. But what happens when you are multiplying or dividing fractions? If you want to multiply fractions, I have 2 fractions up on the board, 4/3 times 7/5. How do you multiply them together? You multiply numerators times each other, and you multiply the denominators times each other. So you're going to take 4 times 7 and divide by 3 times 5. So you end up with 28 over 15. And there's your answer. It's reduced. You do not have to change it into a mixed number, but you have your answer. The next thing we have then is division of fractions. And how do you divide fractions?
You keep the first fraction, then you flip the 15. Yeah, keep, change, flip.
Keep, change, and flip. Something that I think Mrs. Grabenstein started it. Now Mr. Levine is doing it. Keep, change, flip. So you keep the first fraction. What does change mean? You change the division to multiplication and flip the second fraction. So 15/8 would become 8/15. And then you multiply, which means you are going to take 4 times 8. I'm just showing this just for your purposes. And 3 times 15. So what is 4 times 8? 32. And what is 3 times 15? 45. So you end up with 32 over 45. Now that is reduced. And some of you are going to go, well, how do I know to reduce 32 over 45? You can take these individual factors of 4, 8, 3, and 15 and see if anything cancels within them, which are smaller numbers and easier to do, but nothing reduces there. So I know that 32 45 is correct. You have, what happens if you multiply more than 2 fractions together? You don't have to go 2 at a time. If I were to set this up, I could just say it's 3 times 5 times 21, and the denominator is 5 times 6 times 23. But as you look at that, what can you do? Cancel first. Why try to get these really big numbers of 630 over something? Why do that? Cancel first. The 5s will reduce with each other. What else will cancel out of those factors? 3 and 6. 3 goes into 6 twice. So now what you end up with is 21 over 2 times 23, which is 46. And I know that's reduced. I know that's reduced. And I don't have to work with such large numbers and try to figure out if it is reduced. All right, what I have for you then on the top problem here. 7 times 30 over 3 times 9. Multiplication, we're going to take 7 times 30 over 3 times 9. 3 and 30 reduce. 3 goes into 3 once. 3 goes into 30 10 times. Does anything else reduce? No. So your answer is 70 over 9. If you write it out in this format right here, you realize where you can cancel. Sometimes people think you can only cancel here, across, but you can reduce within one individual. This right here, what happens if I would have took 7 times 30 over 3 times 9? Could I have done this? 3 goes into 9 3 times, 3 goes into 30 10 times. That still gives you 70 over 9. It's just that you are simplifying that fraction right there first instead of canceling the 3 with the 30. It doesn't matter. Either way will work. What happens if you multiply mixed numbers? Now what? You have to get them into fraction form. What do we call that fraction form? Improper fraction. Very good. We need to convert them into improper fractions. We remember how to convert into improper fractions, correct? 2 times 2 plus 1. You take the denominator times the whole number and add the numerator. So the first fraction becomes 5 over 2. And I am multiplying that times 16 over 3. So you're going to take 5 times 16 and divide by 2 times 3. Does anything reduce? Yes. 2 goes into 16 8 times. So if you multiply, you end up with 40 over 3. Improper fractions first. Now you're going to get into trouble because some of you are going to try to do 2 steps in one here. First, put them as improper fractions. 3 times 12. 3 times 15 is 45. 3 times 12 is 36. So if I multiply, you get 36 plus 1 is 37. So I have 37 thirds. Rewrite the problem as improper fractions, but a division problem. So I need to divide by 6 times 2 is 12 plus 1 is 13, 6. Do that first. Some of you are going to try to do that in one step, and you're going to mess up flipping that second fraction. So to divide fractions, you keep, change to multiplication, and flip the second fraction, or take the reciprocal. Now, does anything reduce? You have 37 times 6 over 3 times 13, and 3 goes into 6 2 times. What's 37 times 2? No. 74. You were close. 74 over 13. 74 thirteenths. And you know that's reduced because you've looked at the individual factors. So it helps you to reduce them. What does a fraction bar really mean? Division. So if I wanted to work through this problem, what is 3 1/3 as an improper fraction? 10 over 3. This fraction bar right there means divide by. Now, what is that denominator as an improper fraction? 11 over 5. So it's a division. You're going to keep, change, and flip. Does anything cancel? You have to change it to multiplication before you reduce. Do not try to reduce right there first. You have to have it as a multiplication problem first. So you're taking 10 times 5 over 3 times 11. Does anything reduce? No, so you end up with 50 over 33. 50 over 33. turn to page. In this lesson. All right, we have symbols of equality and inequality. What are symbols of equality? An equal sign. So equality means that something is equal to something. Inequality would be greater than, less than. Those are inequalities. We have something known as the trichotomy axiom. Tri means three. The trichotomy axiom is going to guarantee I'm going to win if you're willing to bet me. And what the trichotomy axiom says is it says you pick a number and I'll write down a number. And I want to bet you $100 that my number will be larger, smaller, or equal to your number. Let's do it. Okay, pick a number. Oh no, pick a number. You tell somebody, pick a number. Okay, I pick 4. Is my number smaller than, equal to, or greater than your number? No matter what number you pick, will mine either be smaller, equal to, or larger than your number? Yes, it will always be true. So the trichotomy axiom says it's going to be one of those three things. What are the basic operations of arithmetic? Addition, subtraction. We have 2 more. Multiplication and division. The 4 basic operations of arithmetic. We've already worked with them with fractions. But what happens if you were to add these 2 decimal numbers together? With a partner, you get a couple of minutes. I'll give you a minute. Go.
3.
Okay, so when you add decimals, what do you have to do?
Line the decimal up.
Line up the decimal point. So you're going to have to be neat about your work, because if you're going to be sloppy writing your numbers and stuff, they're not going to line up and it's going to be difficult to add them together. So make sure you're just nice and neat. You line up the decimal point. And how come I don't have a number above the 3? What can you do? You can add a 0. Those are called terminating, or they're called terminal zeros, and you can put them in or remove them whenever you need to be, whenever need fit for whatever problem you're doing. So now you just add each place value together. Bring the decimal point straight down. And is this what you received for an answer? Okay. What happens if you were to subtract them from each other? You don't always just put the biggest number on top, because when you start getting into integers and working with integers, it's not going to be that way. But you want to subtract this from this. So your largest number in this case will go onto the top. Do you remember the word subtrahend, minuend, and what's the answer to a subtraction problem called? Difference. When you subtract them, you line up the decimal point again, but now it's even more important that you put that terminal 0 there, because it's just not 3. Because you don't have anything there, it's not bring down the 3. What you're going to have to do now is put the terminal 0. 0 minus 3, you're going to have to borrow. The 6 becomes 5. 10 minus 3 is 7. 5 minus 6 you can't do, so the 1 becomes 0. The 5 becomes 15. 15 minus 6 is 9. 0 minus 1, you can't do that. You can't borrow from 0. You can't borrow from another 0, so what do? You go from the 4. The 4 becomes 3, and this first 0 actually becomes a 10. But I have to borrow from there to make it 9, to make the next one 10. but you have to borrow from there, making it 9, so that you have 10. 10 minus 1 is 9. 9 minus 2 is 7. 9 minus 0 is 9. And you have your 3. Line up those decimal points. You have to be nice and neat about it. If you're scrunching things up and not making it too neat, it's going to make it difficult. How do you multiply decimals? You just multiply. Do the decimals have to be lined up? No. And if you were to do this, I prefer to put the shorter number, one that has fewer digits, on the bottom. But in this case, it really doesn't matter because this right here only has 2 digits you're going to be multiplying by when you talk about 16 thousandths. So you're going to take 4.06 and you're going to multiply by this number. Now, some of you say that's longer. I would prefer to write it as 16 thousandths times 4 600ths. I don't care which way you set it up, you're going to get the same answer. If you multiply 6 times 6, 36. 6 times 1 is 6 plus 3 is 9. 6 times 0 is 0. 6 times 0 is 0. Now you bring down your 0 as a placeholder and take 0 times everything. Now you bring down what? 2 zeros. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. Now you add those together, but what is the last thing you have to do in your answer? You have to count. So you have 1, 2, 3, 4, 5. 5 digits after the decimal point. So we're going to move it 1, 2, 3, 4, 5. Who is that? And when you move it over 5 places, please rewrite your number and don't leave the swoops, because if you leave the swoops, I don't know which way your decimal point actually went. Is your decimal point right here, or is your decimal point right here? I don't know. So just rewrite your answer. Now the same thing could happen over here if you choose to use the other format. 6 times 6 is 36. 6 times 0 is 0. Plus 3 is 3. And 6 times 4 is 24. Now you bring down a 0. 1 times 6 is 6. 1 times 0 is 0. 1 times 4 is 4. And then the rest are all going to be zeros. So if you add them together, you get 6496. But then you move your decimal point over the 5 places, and you get to that answer. Your assignment for tomorrow. You can keep it on your 1 through 4. You have 1 through 4, and you need to add to that 17 through 27.